So, very good afternoon to all members gathered here. I welcome you all for today's research lecture series on simulation and modeling of multi-robot work cell layout. So, in this presentation, we are going to discuss about the characteristics and features of simulation for a practical real-world system, especially automation tasks carried out by the industrial robots. The type of problem environment selected for a discussion multi-robot work cell. I hope previous lecture we saw about single and multi-robot work cell system as a trade map comparison. Now I am specifically focusing on multi-robot work cell. So how simulation and the CAD modeling, that is the virtual 3D modeling of each and every the components can be done with the help of the simulation software for automotive assembly work cell with the help of the multi-robot system. Now let us get into the session objectives. The main purpose of using simulation and modeling practice inside the production shop floor is to avoid the costly mistakes by the human manpower. And next thing is optimizing the complex behavior of the mechanical system and advancing the manufacturing process with the help of the automation task. So for this thing, we require a simulation software interface application. So before going to implement physically, we need to check it with the help of the 3D modeling and simulation practice, how the real system is going to behave actually in the physical environment. So with that results, we can able to avoid many number of the pitfalls or errors. So by avoiding that, we can safeguard the risk by enhancing the overall the business efficiency by allowing the engineers to create a virtual environment with the help of digital twin technology. Using that, we can forego the following process like testing, planning, and coordinating multiple activities inside the assembly shop floor system. Now let us straight away connect to the subject topic. So what is exactly a multi-robot work cell system? So based on the physical illustration as shown in the picture, so multi-robot work cell is nothing but a joint collaboration of two or more industrial robots working together parallelly by doing specific task, repetitive tasks like welding, material handling, sealing, even sometimes assembly operation inside a well-defined fixed production area. So this is nothing but the problem definition or the problem statement for multi-robot work cell. What are the common typical examples, automotive examples for which we can implement the multi-robot work cell? So manufacturing the automotive body frame in the welding cells, then door assembly, then gearbox assembly, powertrain assembly. For doing pick and place operation using material handling. So for these activities, we can go for the multi-robot work cell optimization. Why simulation is very important and crucial. So through simulation, one can able to avoid the expensive mistakes. So the first thing is we need to validate the each and every the robot interface system and its relative payload capacity before going to start any activity and perform the collision check from one robot to another robot. Accordingly, you have to design the cellular layout by considering the collision related problems. Then optimizing the cycle time, that is the work completion time. Then verify the task scheduling, that is sequencing and coordination. At last, consider the safety layout for doing all the activities with utmost care. So for planning these items, we require a simulation. Directly, it is not possible to go and test physically. So what are all the common thing one can able to simulate in a robot work cell? Defining the cellular layout. So within the cellular layout, we can study the area to be occupied for mounting the robot assembly and defining the arm orientation according to the coordinate axis, then placing additional jig and fixture, conveyor assembly, then defining the operator zone and other safety devices. So everything we can able to keep within the cellular layout in amicable way without affecting the subsequent parallel process. Next one is identifying the motion and coordination through simulation exercise. For arm path planning for each robot, we can do the simulation test. Based on that, we can identify which is the simplest path motion of the robot arm. Here, trajectory path planning is one of the main concepts that can be applied through robot motion and coordination with the help of the simulation interface. Then synchronize the parallel activities or tasks carried out by two or more robots. Then controlling various tool changes. The main key challenge for doing all these activities, we need to carefully consider the collision check while maintaining the talk time or the job completion time. If there is any collision that may extend the talk time, we can't able to complete the job as per the prescribed deadline. So without hitting the parallel robots while doing multitasking, so we need to carefully study each and every activities. So for doing so, simulation is a very helpful tool to study the robot motion and coordination of every job operation inside the assembly cell. And next thing, depending upon the task nature, so what are all the various the job activities we can simulate in real time? Welding operation, assembly, then material handling. So for this hardcore, the typical physical operation, it is highly best enough to perform the virtual simulation with the help of the digital twin. Based on that, we can go for the final implementation in a much simpler sense. Then optimizing the cycle time and throughput using simulation application. To study the individual the characteristics of industrial robot in terms of cycle time, then perform parallel sequencing operation, identify the bottleneck, the most troublesome problem inside the assembly cell, based on which the following outputs are generated. Say, what is the total cycle time inside the assembly line, percentage of the work utilized by the parallel robots, and what is the idle time by which the work is not carried out. So these are the simulation study analysis so we can able to perform for cycle time optimization. Next one, safety and standards. So above all, while doing a simulation, we need to consider safety as one of the prime importance. As per ISO 10218 13849 regulatory compliance, So all activities that is carried out inside the automobile assembly system must undergo safety systems. Say for example, sensors, laser scanners, okay? So part handling systems, say pallet, even automated conveyor system, everything must be handled with utmost safe. So what are the common simulation software tools that are used by every companies in actual practice as per the today's trend? So these are some of the names of the software, the simulation software. So that has been listed out here for your kind reference. So this slide explains about the typical workflow of simulation exercise. So first and foremost thing, we have to create a 3D CAD model of the physical object that you are going to test it. Say for example, automobile body frame, fixture and supporting tools. 3D image of these items has to be represented. Then place the robots inside the 3D model of assembly cellular layout and define the work envelope. Work envelope is nothing but identifying the maximum, the coverage area of industrial robot, the maximum distance by which it can move and pick the various objects to do the physical activity. Then assign the task to each robot, program the path, then perform this collision test. From that, you try to optimize the cycle time, then export the program to real controllers. So this is the typical workflow of simulation exercise. Let us discuss a small simple example, automotive welding cell. So in this example, how we can integrate the simulation and modeling of multi-robot assembly system. So here there are 4 parallel robots equipped inside the automotive welding cell. So each robot has got its own the task assigned to be performed. Robot 1 and 2, the first two missions dedicatedly involved for doing only spot welding on the left side of the assembly unit. The third robot will do spot welding on the right side of the assembly cell. The last one, the fourth robot, equipped only for doing material handling, tool repositioning activities. All the 4 robots are controlled by the PLC logic system. So this explains about the hierarchy, the cell architecture of simulation work environment. So before moving to the final, the closure of the seminar presentation, I would like to conclude the main theme of the topic that we are seeing now, right now. So based on the introduction and other supporting basic information, I would like to conclude that simulation and modeling of the multi-robot automotive work cell system plays an important role in the design and optimization of assembly environment. By preparing a virtual representation of the work cell, it is highly possible enough to analyze the layout of the each and every production activity that has been carried out in a well sequenced way. This approach significantly reduced the product development time and also reduce the errors in the design cost of the product. At the same time, controls the risk associated with the trial and error on the shop floor system. So through automation, simulation and modeling exercise considered to be less expensive compared to real world practical assembly system. And now I acknowledge the following important members who guided me directly and indirectly for preparing this presentation. I propose my acknowledgement to all senior faculties in engineering departments, especially core mechanical engineering. Next, I acknowledge my teachers who taught me the course on industrial robotics during my PG. Overall, I acknowledge all industry persons, academic leaders, and students from various engineering institutions. Once again, finally, I thank all the member participants who have attended today's online session on simulation and modeling of multi-robot work cell system. We will meet in the next lecture series under the research domain, latest research trends in mechanical engineering. Thank you all.